My last slides are about the causality, assessing the causality in medicine or generally in science. These are the decisions, because our statistical analysis or research, whatever study design you have, maybe a cohort study, case control study, randomized controls, whatever you do, you collect some data and you try to come up with a decision. And your decision is what? Your decision is expected that you have a relationship between the diseased and healthy people. You want to decide whether there is a relationship between cause and effect. And this actually is not that easy to decide. And they have this Hill criteria, known as the Hill criteria. We have these 8, 9, 10 points, which will help us to make a conclusion if we are trying to assess causality. What are these? First, the strength. How large is the association? So the p-value or the odds ratio. Is there a very high relative risk, or is it subtle? Is it low? Consistency. Is it only one study or multiple studies? Do I have many studies repeatedly bringing up always the same results, or are there conflicting reports? Then specificity. Does one exposure lead to one outcome? Because if it is direct, if it has direct relationship, then you by taking this product, you should have this outcome always, and it should cause nothing else. Okay, and temporality. Does exposure precede outcome? Of course, exposure precedes outcome. If somebody got lung cancer and then he started to smoking, you cannot accuse tobacco for lung cancer because he started smoking after he got lung cancer. So the cause should, of course, this is very logic, precede the outcome. Number 5, dose response. There should be a dose-response relationship to claim a causality. If you increase the dose, if you increase the tobacco dose, the risk of lung cancer should increase. And of course, you should be able to explain this biologically. What's happening? What is the tobacco or the contents in tobacco causing to end up with cancer biologically? What else? Coherence between epidemiological and laboratory findings. Because this causality only in laboratory, it will not go. You need to show it also in the community, in the people, under the people. Number 8, experiment. It is possible to appeal to experimental evidence. So in the laboratory, in animal experiments, for example, you give one group, this is cruelty, you will say, but you give one group tobacco fume, and the other one breathes healthy air, fresh air, and you see whether it is causing a lung cancer or not. What else? Analogy. Is the association similar to established similar ones? That is another important point. And lastly is reversibility. Does risk decrease after exposure is removed? So if you remove tobacco from the life of the person, will he have still high risk of lung cancer, or will this risk also decrease? If you have many or all of these points, Hill criteria together, only then you can claim a causality. Just 1 or 2 slides more to explain you this relationship, this causality. Here, a dose response example, for example, lung cancer deaths per million men per year. Non-smokers, if you don't smoke, 10 people of the 10 of a million, 10 of a million get lung cancer, even they don't smoke at all. But if they smoke 1 to 14 cigarettes a day, the risk increases to 78. 15-24 cigarettes, 120. 25 plus, 450. This, you see, there is a very clear dose-response relationship. Okay, that's one in the pocket if you are trying to make conclusions on tobacco and lung cancer relationship. Reversibility. This is a famous British study called the British Doctors Study. British Doctors Study. I suggest you to follow the link to read the Wool report. It is very good, I believe, a very nice research to convince yourself or your patients about the harms or risks of smoking. Look, mortality rate relative to never smokers by years since stopping smoking. If 0, the mortality rate is 15.8. If 5 years, 10. 9 years, 5.9. 10 to 14 years, 4 points. As you see, if somebody has quit smoking 15 years before, his risk is decreasing to 2. So there is a reversibility. Although all these people were smokers, if he quit smoking at age 24 to 34, 25 to 34, his risk, as you see, this red line, very close to the healthy people, non-smokers. If you stop smoking later, 35 to 44, the gap increases. Quit smoking after 45, the gap is very large, and it is never being able to catch the healthy people. And after 55, so there is a reversibility. That means you can, using the Hills criteria, you can claim a relationship between, causal relationship between tobacco smoking and lung cancer. Okay, what did we discuss today? Although I had very simple 3 objectives, these were very important and detailed objectives. There we discussed the different study designs and their futures, and we discussed the incidence, prevalence, positive predictive value, negative predictive value, relative risk reduction, number needed to treat, odds ratio, relative risk, a lot of epidemiological terms. Many of them you were already probably familiar, but you must understand them very clearly in order to understand, in order to be able to make an evidence-based decision, in order to practice evidence-based medicine. So I strongly suggest you to review this today's lectures, today's presentations, and try to understand. If not, please write in the forums to discuss and make it clear, clarify it. Take care. Until the next presentation, bye-bye.